Hello, everybody, and welcome to today's Odtn use case call. Thanks for the few folks that joined. It's a long time since we had one of these, so glad we could get back to it and get something going on. So first up, I would like to leave the floor to Alessio from CNIT to have some updates on the work that they are doing on different elements, starting from the ECOC demo to an update on the Momentum Rodum drivers and some cross-connects commands.
Okay, thank you, Andrea. So I'm going to share, trying to share the, can you allow me to share?
Yeah, I can actually stop sharing myself.
Okay.
There you go.
Yes. Okay, so I would report some information regarding this work that has been presented as a demo session in ECOC from remote. So it was a weird demo session because it's almost an oral presentation with few demonstration from the command line of ONOS. However, the idea was to find a solution to control a multi-layer network with an optical transport layer and a packet layer that includes also these hybrid nodes that are packet nodes equipped with coherent pluggables, and therefore, so they are, from a formal point of view, they are packet nodes, but they have to configure the pluggables, transmitters, receiver to with some optical parameter that may have an impact, for example, on the route wavelength assignment on the optical transport plane. And to solve this problem, we have applied a hierarchical solution where we have a packet dedicated to the file, to the packet, a controller dedicated to the packet layer, a controller dedicated to the optical layer, and then a hierarchical controller that is coordinating the action and the exchange of information regarding the two controllers, among the two controllers, between the two controllers. So this is the workflow of the demonstration. So essentially, we have first this initialization phase where we have to post or automatically load the topology in the two child controllers. For example, for the packet one, the P4 topology is once you push the device, the links are automatically discovered, while for the optical layer, you have to push all the devices and the links. Once you have configured the child controllers, the parent, where we have developed a specific application, can get the topology, devices, links, interfaces from the children using the REST-based communication. And here also then you have to configure the pluggables links that are these black links that connect the pluggables in the packet layer to the optical port of the ROADMs. And then for the configuration, we have designed this kind of workflow where we receive a request for a multi-layer connectivity, for example, starting from there and up to there, that has to pass through the optical domain. Here we forward the connection request to establish the light path on the optical plane, and also here we communicate which pluggables models are available at the packet layer, so that the optical routing wavelength assignment can take in consideration the models that are there, considering, for example, the supported modulation format, no? Or the possible tunable range and so on. Here we are assuming that the routing spectrum assignment in the optical transport layer can be also performed using dedicated software, for example, GNPy and so on. Once the configuration is performed, so the child communicates back to the parent that the configuration is okay, and which are the parameters that should be used for the pluggables. For example, which is the central frequency to be used based on the spectrum assignment, but also which is the modulation format and so on. And then only in this phase, the parent contact the packet layer controller, where here we have not only the intent request from on the packet topology, but also here we have the pluggables parameters that should be applied by the ONOS by the children controller. Here we are assuming then that the packet layer controller communicates to the hybrid nodes using two different protocols. For example, in this case, we were using the P4 runtime and netconf for the specific configuration of the pluggables. But the important point for us here, the important contribution is that we are, how to say, retrieving this information, the pluggables parameters, configuration parameters from the optical controller, and then through the parent controller, we are passing this information to the child controller that will perform the configuration. And this is this contribution. The next slides are just to report more details regarding the used REST interface. Here we have assumed that the pluggables are modeled using following an OpenConfig specification. So we have these three parameters: frequency, transmission power, and this operational mode that enclose all the other parameters. Because this is the approach of the OpenConfig. And this is the test bed where we have tested the system. In particular, here we have some real device and some emulated devices. The real devices were the Mellanox switches, while these P4 switches are emulated but used on a server, but using real physical interfaces. The traffic is generated with a firing traffic generator. And also the pluggable here was not physically present, so we have emulated the pluggables with an Ericsson transponder. And then this is the architecture of the software inside the Mellanox. So we were using Sonic, where we have deployed two separate Dockers implementing the P4 runtime switch, the P4 switch, and a netconf agent devoted to the, in theory, to the configuration of the pluggables, in practice to the configuration of an external transponder. And this is the testbed, the devices included in the testbed, the physical ones, and this is the three graphical user interfaces for the three controllers. And this is all for this point. I don't know if there are questions.
I think this is a great demo and great explanation, and it's a great set of work that you guys did. Well, one is the demo video. Is it publicly available?
Yes, we have just uploaded two videos. One is these slides, and the other is the live session. So I can share with Andrea the link to the live demonstration. So essentially, we do in the live session the two phases: the initialization phase and the configuration phase. Obviously,
yeah,
you know,
that would be good, Alessio, if you could share that. Thanks.
Yeah, sure. Then I would also report on the on another work that we are doing it together with the Politecnico Torino and for the next coming OFC, where we are extending a bit the drivers. The idea is to implement, let me share a slide. Here, the slides are very, in a very, initial phase. However, the idea is to control the real testbed that is in the Politecnico of Torino, where they have 3 Lumentum ROADM. Here for the Lumentum, we have already the driver into the ONOS repository, but we have just yesterday or on Friday, we have just submitted a patch to the driver that is for supporting also the firmware version that was available in Turin, because the previous version was made testing only in using the firmware version that is available in Pisa, in the device in Pisa. So essentially, I tested the drivers on this more recent firmware, and I have updated the driver in a back consistent way to support both versions. And the other one, the other patch, I don't know if I can. Let me see if I can connect to Garrett. I can share the dashboard, and then this one, this one is the patch to the Lumentum driver. Essentially, we did very small modification to both the ROADM discovery and the flow rule programmable, just to adapt to some string improvement that occurred in the model. The other one, the other patch, is this one, applied to the wavelength config command that was before used only to configure a wavelength on a line port of a transponder. Now I have a bit, updated this same command so that it can be used to both to update the line, to configure the line port of a transponder, but also to send a cross connection to a ROADM. So here I have added into the input parameters 2 ports. So now we have the input and the output ports. In the case of transponder, we have to use the same value for the 2 ports because we are configuring a single port. And then I have added also the possibility to delete the configuration. It was not supported. And some, some check styles that just to improve the output of the application. This is all, I guess, from my points. There is still the ADVA driver bullet I see in the outline, no, Andrea?
Yes.
Also on this point, I have no.
Before we go there, Alessio, why don't we stop a second and ask if there are any questions from anybody?
Sure.
If Michael has any questions.
Not really, actually. I think there's a ROADM GUI app, isn't there, as well? Did you?
Yeah, there was.
Did you address that?
Yeah, because I guess Andrea can be more. Can be more specific. At best of my understanding, the current version of the GUI application is not able to send a flow rule. After the upgrade to the GUI version 2. So since we have this command on the CLI, I have updated this command so that now we can use this mainly for, testing and debugging test when we have to develop, to update a driver and some, because this This is the reason why, because I was updating the driver on the Lumenton, and so I needed to send a single flow rule to the device to check if it was working fine. So I found this way. The other way was to add back the flow rule, the possibility to send a flow rule from the graphical interface, but I'm not familiar with the GUI, with the GUI component, so I prefer to go this way.
There's a couple of things. One of them being that it is not entirely true that you cannot add it anymore. If you go into the UI, there is.
I can. Let me
you can
see.
bring it up. Maybe we can check it.
Well, here, this is a controller where I have a RODM loaded. We could start the application is RODM, no?
Yes.
It's RODM that is this optical application, no?
Yes.
If okay, we can try to start just to see, because these are some graphical. Okay, so you can access from here. We have the RODM, and then before, I remember that when you click in the previous version, when you have selected a device here, you have also the possibility to send a flow rule. But now you can only select the port.
Yeah, go ahead in the port.
Okay.
But because okay, so if this RODM had the flow rule programmable driver, I think it should show up in current frequency, and you should be able to set that.
Show device table from here, maybe. No, this
no,
is
no. It should be from here. It should be from here. That you can set the frequency where the current frequency is written. You see current frequency in terahertz. You should be able to set it. You should be able to set it. You can do it for the transponders. It might be that you have to make a small adjustment, very similar to what you did for the CLI command for the transponders.
I don't know, but here why it is not, because the programmable is there.
Yeah. Do you want to? I think because there is a hard-coded check for the device type. Most likely, there is a hard-coded check that checks for this being a terminal device or something like that. And we can probably get this code. You can maybe ping me offline, and I can find this for you. Most likely, it's a fairly small fix. Not 100% sure of this, but probably it's a fairly small thing.
Yeah, for sure. Having in the graphical interface is nice and better than from the command line. So please let me know.
It makes it good for demos, doesn't it? I think.
Yes, exactly.
It does. Okay, let me. I'll have to check. It should be a fairly quick check.
Yeah. Okay. In any case, it is useful also from the CLI. So just to have the two possibilities.
Okay. Anything else?
No, the rest was if you want an update, but I have no news for the ADVA driver.
Yeah.
Yeah. But the good news, as I've mentioned in the last time, is that we are going to start on this new project that is with the same consortium of Metrol. ADVA is there, so probably once the project started, for sure, ADVA we will start to work together again in the project. So for sure, this is something that will be, reboosted, we can say, no?
Is this Terraflow, Alessio?
And
Is this Terraflow?
No, it's a new, it is B5G open that was rejected last year, but it was the first one in the, in the backup list. And it has been founded just a few months ago. So it's going to start, I guess, in October. So, so we are very happy to go back to have funding for working together in this activity, this kind of activity, you know? And also the hierarchical structure of the controllers is also part of this project. So we are going to start from that point and further, work on it.
Okay.
Nice.
I can stop the sharing.
Yep. Let me get it back. Okay. So next up, there was some updates from Roberto, whom I don't see on the call, so I'm not sure what the update was.
Yeah, if I will remember, it was the update of the OpenROAD driver.
Yep.
I promised to review it, but we since the OpenROAD driver was used for the demo ECOC, so I delayed the review after the ECOC demo. So in the next weeks, I promise again to have a look to the patch. If I will remember, was an improvement that Roberto did, also removing the local connection cache. So it is a quite big, in my opinion, quite a big update. So my idea was to have a look and also to test it on our emulated devices before closing the review.
Mm-hmm.
I know Roberto tested already. Yeah.
Okay. Yeah, I'll have to review it as well. I haven't. Same here. I haven't had the time, so I don't really. Yeah, I didn't have the time to review it. That I'm sorry.
And I see several patches from for the Polaris driver, no, in the recent days.
Yes,
that's
so
right.
that is the next bullet on the agenda, actually.
Yeah.
So, Michael, do you want to give us an update on that?
Yeah, let me just can I just share us? I've got a few. I can show a few slides actually, just to put it into context, if you like.
Sure, absolutely. Let me stop sharing myself.
Can you see that?
Yeah.
Yeah.
Okay, so just to put it into context, this is the drivers in ONOS for the Pilatus all optical switches. So we were inspired really by a customer request a few years ago to implement a netconf driver. In fact, I think at the time, my colleague who did this work, he implemented both a netconf and an OpenFlow driver, because at the time we had an OpenFlow agent as well for the optical switch. We've kind of abandoned, I have to say, for the OpenFlow agent, we've abandoned that sense really, because Nobody really seems to be using OpenFlow for optical devices, at least an optical switch. So we concentrated instead on netconf. And so my colleague Laszlo Papp did that quite a few years ago now, actually. He's since left us, actually, and he's gone into a completely different area of coding, different industry area. And so it was long overdue to kind of fix a couple of bugs in that driver, but also to add a few new features. Again, this was in response to some customer inquiries about that. So these are all optical switches, photonic switches, essentially, or fiber switches, however you like to call them. So optical connections in, optical connections out, and everything on the fiber, everything on the in this optical spectrum is switched in one go. Yeah. So let me just to explain that a little bit more detail. Essentially, what's inside the switch are an array of input fibers, an array of output fibers, and some mechanical actuators with collimating lenses. Collimating lenses on the ends of the fibers, and then those collimating lenses are steered at each other. We call this beam steering technology. Direct light is the registered trademark we've assigned to it, and we collimate the signal very accurately and direct it across a free space gap. So it gives you an N by N switch, and the way we construct these things, we can build them up in a very modular way, so that you can be a symmetric N by N switch or an asymmetric switch with fewer ports on one side than on the other. And we can build them up from small switch sizes, as low as 4x4 or 8x8, up to our largest size, 384x384, and soon we'll be going larger than that. But anyway, there's let me just move on and sorry, there's a little animation. You can see essentially how the switching is implemented. And then the rack mount switches, they have a controller in there, and we've implemented a number of protocols, and you can see here those protocols. It includes netconf. Like I said, we did OpenFlow a few years ago, but we don't really do that anymore. So a lot of the time people are using netconf or restconf or SNMP. For direct access to a CLI, they're using TL1 or an old protocol for lab equipment management called Skippy. And here you go. Here you can even see a screenshot from ONOS. So we illustrate how we through these interfaces we enable us to integrate with controllers such as ONOS. So what I've done, so just a kind of simple logical view of the switch. There are input ports and there are output ports, so I've done, like I said, the driver updates have fixed a few bugs, essentially fixing an issue where the switch software version, the switch name, and the firmware revision and so on, parameters like that were not being retrieved properly, but now they are during device discovery. But I've also implemented a few other behaviors at the same time. So one of them is a form of link discovery. It's the beginnings of a form of link discovery. So each of the in our switches in the data model, each of the ports, as well as having a numerical ID, it has a free-form label, and it also has a parameter associated with it called peer port identifier, and that's a free-form string. And the intention there was that could be encoded with information about what was on the far end of the link coming into that particular port. So that one, that at the moment the switches don't automatically discover their neighbors. If we've thought about various ways of doing that in practice, bearing in mind this is a transparent all optical switch. But until a customer demand really comes up for that, then we wouldn't actually implement that. So as a sort of stepping stone in between, if you like, it's possible to manually configure this peer port ID, perhaps during installation, perhaps during commissioning, So what I've done with the link discovery behavior is to pass that field, the peer port ID, and look in there for a snippet of JSON taking this structure here, this form here, where a peer is identified by an ID. It takes the usual protocol : IP address : port number format, and then a numerical port number. So it'll pass that and then use that to check the far end, check that there's an appropriate peer port entry on the port that's been indicated on the neighboring switch, and having done that, it will then add a link. So that's the link discovery behavior, and at the same time I thought I'd add a few other behaviors. So I've implemented port admin, so the ports can be enabled or disabled in these switches. What that means, it's not a shutter function as such. What it just basically means is that when a port is disabled, if you try to create a cross connection to it, then the collimating lens will stay stationary. It won't be steered in the direction of the port that you asked it to be connected to. So that's a kind of just a port enable disable feature. So that's been implemented. So I've implemented the port admin behavior to update that. I also implemented the internal connectivity behavior as well. So I think was a behavior that was added fairly recently, wasn't it? That came out of the Metro Hall project, if I remember correctly. So I've implemented that as well. So therefore, that it will generate a list. So for a given input port, it'll generate a list of possible output ports that can be connected, and it will exclude any port which has already got a cross connection, and it'll exclude disabled ports as well. And also it will exclude ports that are on the same side of the switch, because on a two-sided switch, such as I'm showing here, port 1, for example, couldn't be connected to port 2. So if you try to do that if you try to test for that using the internal connectivity behavior, then that would come back with a negative. And I think that's it really. That's the extent of the updates that I've done to the driver. I gather they've just been merged. Any questions about that?
I was up to date during the whole process, so I think it's a pretty good. Update and worthwhile having in ONOS. It helps definitely with your device. Yeah,
it helps it, so sure. Yeah, I mean, we've got a few users. I think that are going to be making use of this actually. So we've sold a few switches recently to various parties, and then I know that they've been wanting to use ONOS, and so they'll be happy to see these driver updates.
That's good. It's good to know. One quick question on that front. Which version are you working on with master on these things, or the customers that use these with existing ONOS work on a previous version of ONOS, like 2.5 or something?
Well, I think the customers that are using at the moment are using various versions, 2.5 backwards. I think.
Okay.
I can't remember which versions they're using, but
that's fine.
I guess the Pilates drivers are in all of them. You know, the older one.
Oh yeah, the older version, yes. These, if you're interested, what I can offer is that we could backport these to 2.5 with the 2.5 being an LTS release. We could update the drivers and fix a few things within that release.
Yeah.
It would be up to you to do the work if there's any work to be done, but.
Let me find out from these particular customers. Actually, I mean, you know, if they're kind of that might be useful actually.
Yep.
Can I just add something else actually?
Sure.
Another customer also using or who's wanting to use ONOS to control our switches was asking about a netconf call home, and
yes.
So we've actually done a rudimentary implementation of that. so I'm ready to. I think I'm ready to upstream that if people want to take a look at it and review it. It's not a. It occurs to me that it is not a full implementation of netconf call home, for the simple reason.
What do you mean by?
Well, for the simple reason that netconf call home, I mean, is meant to achieve a few things really. So it's a call home functionality, of course, but also it's one that is intended to allow working through a NAT. Or a firewall that it might exist in the management network between a controller and devices. And to that extent, when the call home session is initiated, then if I understand correctly, the netconf session that gets set up should use the same TCP session that was initiated through the call home procedure. Now, what I've implemented at the moment doesn't do that, because I've not found a way of doing that myself. So if there's anybody,
it means that it reopens another session.
That's right. It does. Yeah, exactly. Yeah.
Yeah. So there was a person called Anurag in the ONOS channel that wrote to me about this some time ago. He also had some questions around using the same thing with Pachimina, and I think they also have not found a way. What I can do is I can send you their name, and you can ping them on Slack and see what they are up to.
Yeah, I'll do that. Yeah.
So the name is. Yeah, name is Anurag, and you can find them on Slack or via email. I'll drop you an email with their name.
Yep. Okay. I will look that up. Now, do you think that? I mean, is there an interest in the call home functionality to be added into the netconf device provider?
Yes. There was, so a long time ago, I actually had a document describing. I think I shared it with a few folks. I think you have seen it, and that's what.
Yeah, I've seen it.
The base of the original work that you guys have done. So yeah, definitely. There is a lot of interest. It's just finding a matter of I didn't have the time. So are you guys doing it? It's perfect, and we can definitely get it working.
Well, I mean, like I said, what I've implemented so far is it doesn't reuse the incoming TCP session that's coming from the server, from the netconf server, because in call home the netconf server calls the client, and then the client establishes a TCP a netconf session in the normal way. But what I have implemented though is a rudimentary security check, so that that if you look at the RFC that defines netconf call home, it does require that there is some rudimentary security check. So what I've implemented at the moment is to check when the SSH session is requested, then it checks the known hosts file.
Okay.
This is the known host file on the client side, on the server, ONOS server.
And with that,
I think a full implementation would have
security, and with that, it's good enough of a security that you consider it okay.
Yeah, I mean it's not, again, I think strictly speaking, you should also be handling certificates as well, but I think this is probably sufficient to start with. I can submit and people can comment, I guess.
Yep. Okay. Yeah, that would be good. Yeah, start with the submission, put it up, and I guess we can start from there. I think it's a good proposal. Starting point.
There's already a Jira I've opened for this.
Perfect.
Michael. I'm Alessio. how it is loaded, the which with the which device type? I mean the switch.
Fiber switch.
Fibers. Oh, okay, because I'm not familiar with that part. So did you test for sending the flow rules?
Yeah, flow rules have worked for a long time, and if you create a point-to-point intent, for example, the flow rules are set up.
Yeah.
Yeah, the flow. You're talking about the flow rules programmable behavior. I've not touched that actually. That was the original. That's as it was in the original implementation done by my former colleague.
Yeah. Okay. No, because the format, I mean the fields to be matched in the flow rules depends on the type of intent that you use. So your case, you can only match the input and output port, no?
That's right. That's what's been implemented precisely.
Yeah. So you need this kind of intent that is matching only the ports, and not only the internal connectivity behavior. It was there, but it is still not integrated in the intent computation, no? In the intent compilation.
I noticed this. I was thinking of having a go at adding it myself.
Yeah. If you because this is something that should be integrated in the compilation of the intent, checking this point, and it's something that is open from a while, we can say, no. It's something that we can work on.
Yeah, no, indeed, I've thought about it.
Yeah. And which kind of intent do you use?
Point to point. So far we've just used point to point intent.
Okay. Okay. So because point to point use only the ports. Yes.
Yeah.
If you do not specify any other parameters.
Yeah, okay. It would be nice to get it working with some of the optical intents actually.
Yeah.
Yep.
Yeah.
I mean, to that end, actually, what the driver at the moment actually, it defines ports as optical multiplex sections ports.
Okay.
Strictly speaking, I mean, our switch, of course, works at a lower layer than that. Even at the optical transmission section, I think is probably the nearest equivalent in the OTN hierarchy, but that doesn't exist in the optical model as far as I'm aware.
Because currently the optical intent is automatically assuming RODNs, so is generating the flow rules with the frequency slot, also.
That's right.
So, so if you want to use, so you should define or a fiber switched intent, something like this, or assuming.
Yeah, I was thinking of something like an optical transmission section intent or something like this. But I don't know whether that would mean that the optical model would have to be augmented with another layer below the OMS, because I think the optical multiplex section is the lowest layer in that at the moment.
At the moment, yes.
I think for describing the device you have, we don't have the full capability, as you said. So it might require some extensions. That would not be that bad. I wouldn't be opposed to that. If it's done in the same vendor agnostic way as we have always done things.
Yeah, no, sure. I mean, we'd always do that. Okay, well, I'll think about it and then maybe make some suggestions on Slack or something. Yeah,
sure. Why not? And if you conjure up or put up some document or some thoughts in a more refined way, I guess we can always discuss them at one of these calls. Whenever you have the proposal ready, we can just sit down in one of these calls and discuss it.
Okay.
So on the agenda, I'm not going to go ahead and share it again, but on the agenda, we had some updates from Nokia, but I have nobody from Nokia today. I have to reach back to Dominique and the folks and Hui and the folks in Nokia and see where they stand with things. And the last bullet was actually to discuss the Metro Hall 2, as you could say,
Yeah.
project passing state. So unless you just give us an update before, do you have anything more that's worth sharing about the approval of Metro Hall 2?
So yeah, I can. I'm not. I still have to study the proposal very well because so I have to look into better. So what I know is that it's going to start. The partners are almost the same from with respect to Metro Hall. The activity are still in, how to say, the details of the activity are still in phase of definition, but for sure we are going for using ONOS and the optical model as is already implemented. So this is a starting point. We have mentioned the possibility to work on introducing the flexible grid support. That is something that, in my opinion, should be very useful for using ONOS with the real devices that are now at the commercial level. And for the interfaces on the southbound, the idea is to continue to using the netcom with the drivers that we already have. For the northbound, as I've mentioned, from Telefonica, the main input is to use the TAPI, but the idea is to not use the ONOS implementation of the TAPI, but using something external, and then to have better control of this interface. This is the topic of Ramon. Maybe he can provide more details in the next meetings. Yeah, in the future. And then from this, to say, external TAPI proxy, the idea is to use the REST interfaces, northbound interface of ONOS that could be maybe, to say, upgraded or modified to receive all the needed information. No? But this is something that we know quite well. It is something that we know it works well, and it is easy to be extended and so on. This is what I know up to now.
Okay, yeah, that's still pretty good.
Also, we have in the project we have Telecom Italia with Roberto and Emilio. So I guess they will also continue working on their open road driver and agent, and this is also good.
Yeah, that's great. It's great news. It's really good news that we got this approval, and I also like the few statements that you made. What I can offer is continuously work with you guys on this and help you guys with whatever the project demands. And as usual, we are interested in putting out some work with ONOS. So that's always good to have. I do like the fact that we are moving out TAPI because the implementation in ONOS with the auto-generated Yang model, while it is working, I never particularly liked it. So I think having it out could be a pretty good thing to do. That would be
yeah. Good.
Okay. I think it was a pretty good meeting. It was pretty good information. So I guess as action items, I have to review patches from both Michael and Alessio, what on the things that they submitted. I'll try to do that this week. Worst case next week. This week is a little busy with Volta, so I might have to not do those, or I might do some and not all of them. But I'll try to do them. I'll try to get them done and see where that takes us. There could be some small updates that I would ask of you, but should be pretty straightforward. Yeah, I think that's really about it from my point of view. Unless you guys have something more to comment, I think we can call it a day.
Yeah, for me, we can close.
Nothing from me.
Okay, then thanks everybody, and thanks for joining, and as usual for the great work that you're doing at respective companies and teams. Let me know if there is anything. I think we will try and set up some time, me and Alessio, on understanding that UI part, and I shared with you the information about Anurag, Michael. So I'd say try and ping him. Try and ping him to see what he says about his call home feature that he started putting together some time ago, or even gave some thought about. And yeah, that would be my suggestion for that. And in the meantime, yeah, we'll review the patches and put them in.
Okay.
Okay. Anything else? No? Okay. Thanks, guys. I'll talk to you next time.
Then.
Cheers. Bye-bye.
Thank you. Bye.
Bye. Thank you, Andrea.